Hi, today we're doing lesson 2 from module 3, base 10 and scientific notation. So any number or all numbers already can be thought of having a base 10. For example, 382 can be thought of 382 times 1. So those two numbers are exactly the same. Likewise, you could think of it as having a base 10 because 382 times 10 to the 0 is the same number. That is 382. 10 to the 0 is 1. So these are the same number. It's also 382. Likewise, 2.785, or any number, is the same as 2.785 times 10 to the 0 because 10 to the 0 is 1. So that's what having a base 10 means. You times 10 to an exponent. So let's multiply these first, going from base 10 to a standard number. When this number, the exponent, is positive, you move your decimal place to the right. You move your decimal right. This is only to go from base 10 to a standard number. So here's our decimal place. We're going to move it over here to the right one, so this becomes 34. This is multiplying to a standard number. Now this is positive 3. This means multiplication, so we're going to move it 1, 2, 3. So we're going to have 85.7. These two are equivalent. This is written in base 10, and this one is standard. When you have a negative exponent, you move the decimal left. So think of positive exponents are big numbers, larger numbers. Negative exponents are small numbers or decimals, okay? This is only to write the number in standard form, to go from base 10 to standard form. So this one, the decimal place is right here, 41 point. We're going to move it left 2, so we're going to go 1, 2, and this is equivalent to 0.41. Now 0.41 you could write like that, or you could put this 0. Both of these are exactly the same. 367, we're going to move it left 4, 1, 2, 3, 4. This is where my decimal place goes. I need a filler 0, 0.0367. Again, you could have that leading 0, but you do need the 1 before the 3 for sure. Let's write these without exponents. So rewriting it as a normal number. This 4 is positive, so we're going to move it right. 1, 2, 3, 4. So we get 5, 9, 2, 3, 0. The commas help keep place because you put a comma every 3 numbers. This is going to be negative 3, so we're going to move it left. It's going to become a decimal, 0.0074. Positive 3 is going to be a bigger number, so we're going to move it right, 1, 2, 3, 1887.5. Okay. Now, scientific notation. Scientific notation is a form of writing things in base 10. It's a number times 10 to the n, where the number is between 1 and 10. It shows the absolute value. So the number is going to be between 1 and 10, or between negative 1 and negative 10. The absolute value just means you take the absolute value of that number. So for example, 3.8 times 10 to the minus 4. Yes, that's scientific notation because it's only 3.8, which is between 1 and 10. Negative 2.75 times 10 to the 3. This is scientific notation because this number is between negative 1 and negative 10. If I have a negative 0.5 times 10 to the 4. This is not scientific notation. I'm trying to cross that out because negative 0.5 is not between negative 1 and 10. We have one number and then the decimal point. the number cannot be a 0. Or if we had 10.7 times 10 to the minus 7, this 10.7 is not between 1 and 10. That is not scientific notation. So you take the absolute value of this number, and that number has to be between 1 and 10. Or if you think of a negative, it has to be between -1 and 10. You cannot have 2 digits before the decimal point, and you can't have a 0 before the decimal point. So to write a scientific notation, you locate the original decimal point, and you have to convert it. Remember, you have one non-zero digit left of the decimal point. So, for example, 5.7, -1.8, 9.9, these are all good. So, these are not scientific notation. The reason being, this one has 2 digits right here left of the decimal point. If we had 5.194, and then I'm not sure about that part yet, we'll go over that, but this is scientific notation, this is not. This one has a 0. We want a non-zero number left, so if it was 6.1 with something, then this would be scientific notation. The 0 there before is not. This one has 300, but if we had 3.00, this would be scientific notation. 300 is not. So let's change a number to scientific notation. They are starting with 48,000. So scientific notation, as we know, we want 4.8 because that's between 1 and 10. Now the decimal point is over here on the right, and we're going to move it left 1, 2, 3, 4 places. When you move it left, I know it's strange, but you're going to make this a positive. 48,000 can be thought of 48,000 times 10 to the 0. So when I move it left 4 places, I'm going to add 4 to the 0. And your final number is this. Now look at where you started and what you ended with. 4 is positive, so that's a bigger number. So changing the decimal place or changing something with the base of 10, it's different than writing it as a standard number. We're moving the decimal place left, and so we're adding this 4. Let's start with this number, 2.789 times 10 to the 5th, but we want to change it to 10 to the 7th. We're going to add 2 to go from 5 to 7, and when we add, we're going to move this decimal place left 2. So the new number is going to be 0.02789 times 10 to the 7. It's a little opposite than writing it as a standard number. So we moved it left. Now to check it, you could write both of them as a standard number. So to check, we're going to do 2.789 times 10 to the 5th. That we're going to move it to the right. 1, 2, 3, 4, 5. That's 2.78912. That's that as a standard number. 0.02789 times 10 to the 7th. To check it, we're going to move it right 7. 1, 2, 3, 4, 5, 6, 7. So it's this number and 2 zeros. So these two are equivalent. I often have to check when I'm moving with the base 10 because it's opposite than what I think it should be. This next number, 34.567 times 10 to the minus 1, we want to change it to times 10 to the minus 3. So we're going to subtract 2 to go from -1 to -3, and if we subtract, we actually move it right. So we're going to move it 1, 2, right 2. 34.56, oh, sorry. It's not point. 3, 4, I'm moving it right 2. 56.7 times 10 to the minus 3. Moved it right 2, so it becomes over here. And now to check it, I'll check these down here. Let's start with our original, 34.567 times 10 to the minus 1. That moves it left 1, so it's 3.4 5, 6, 7. And then the new one, 3, 4, 5, 6.7 times 10 to the minus 3. We're going to move it left 3 for a standard number, 1, 2, 3. So we get 3.4567. These two are the same, so we did good. So to write these numbers in scientific notation, the distance from the Earth to the Sun is approximately 150 million kilometers. So we want the decimal place right here, 1.5. That's a good number because that's between 1 and 10. And then we have 10. Now the decimal place is here. We're going to move it left all the way to here. So there's 3, 6, 7, 8 places. And when we move it left, it's a positive 8. A single rhinovirus measures this very small millimeters across. So we want the decimal place right here, 2. We're going to move it to the right, 1, 2, 3, 4, 5. So we moved it to the right, it's actually a negative. So a negative, remember, is a decimal, so these match, and a positive is a big number, so those match. This is in the module. This is starting the module. I believe it's page 9 of ours. So we're going to match the equivalent expressions. I wrote the letters there to try to match these. Your module doesn't have the letters written in. They want you to rewrite them, and I could do that. So 3.5 times 10 to the 5. 3.5 times 10 to the 5. That tells me that it is a big number because 5 is positive. Well, this one's a big number, but there's 1, 2, 3, 4, 5, 6. So it's not B, so it's actually D. If I move the decimal place right here, 1, 2, 3, 4, 5. So that one is equivalent to 350,000. 3.5 million. Well, it's written 3,500,000. E is equivalent to a big number with 3.5. This is a decimal, not that. This is also a decimal negative. It must be this, J, 3.5 times 10 to the 6. Sorry, 3.5 times 10 to the 6. So that's a big number, and we moved it left 6. 1, 3, 4, 5, 6. Negative 6. Negative 6 is a number times 10 to the 0, because 10 to the 0 is 1, so those two are the same as negative 6 times 10 to the 0, because this is 1. Let's do F over here. 6 times 10 to the minus 1. This is telling me it's a decimal. We're going to move it left 1, so it's this one. Left 1. To 6 to 0.6, so it's equivalent to 0.6. So for letter H, which is this one, a decimal point, the small fraction, it's the last one available, but I know it matches because negative 6 would be a fraction. And I'm going to move this to the right. 1, 2, 3, 4, 5, 6. And when I move it to the right, it's a minus. Subtracting. So this is in the module also. Write a number as a decimal between 1 and 10 with the power of 10, which is scientific notation. So we want the decimal point 2.34. That's a number between 1 and 10 times 10. So we're going to move the decimal place to right here. That is left. We moved it left 5. So when we move it left, it's actually a positive 5. That's because 2.34 times 10 to the 5th is a big number, and that matches. On B, we want 3.5 because that's between 1 and 10, and we're going to move the decimal place right 4. So if we move it right, it's actually a negative 4, which makes sense. Negative 4 is a decimal. So I'm going to jump over to 3.31. 3.31 is already between 1 and 10. So we want 10 to the 0. This is with the base 10. These, I'm only going to do a few of them. 8.9 is between 1 and 10 times 10. Now if there's 14 zeros, we want the decimal place right there. We have 14 plus 1, so it's going to be 15. We actually move the decimal place left. And times 10 to the 15 is a big number, which is what that is. On number 5, it's 3.4 times 10. There's 24 zeros and then the 4, so it's 25. We moved it left, which is a positive 25. This one is 4, because we want the decimal place right here, times 10. There's 21 zeros and then another one, which would be 22 for the 4. But we move the decimal place right, so it's a negative 22. This is a small number, a negative exponent. So here are some facts about the Sun and the Earth and Jupiter and Pluto. The distance from Sun to Earth is 1.51268468 times 10. We're going to move it left 8 places. So if we move it left, it's actually a positive. This one, Sun to Jupiter, is 7.8 times 10. We're going to move it left 8 places. And if we move it left, it's adding 8. Pluto is further. It's 5.9 billion, so it's 10. And we're going to move it left 3, 6, 9. So it's 9. Now, how much farther is Jupiter from the Sun than the Earth is from the Sun? So for these, we have to subtract them, and we're looking at Jupiter and the Earth. For Jupiter and the Earth, they are both 10 to the 8. So all you have to do is subtract 7.8 minus 1.51268 468, and these are times 10 to the 8 times 10 to the 8. Since they're both 10 to the 8, you just subtract these two numbers right here. 7.8 minus that, and you're going to get, sorry, I'm doing it, 7.8 minus 1.51268 468. Your answer is going to be 6.28731532 times 10 to the 8. You keep the same power with that. This last one is Pluto and Jupiter, so these two right here. Now they have different powers for 10, so we want them the same. So first, I'm going to change Jupiter's to 10 to the 9. So I want times 10 to the 9. If I'm going to add, I'm going to move left 1. So I'm going to move it like this. So it's 0.78 times 10 to the 9. Now that they're both 10 to the 9, I could subtract them. So we have 5.9 times 10 to the 9 minus 0.78 times 10 to the 9. So 5.9 minus 0.78 is 5.12 times 10 to the 9. That's the difference. Difference is subtraction. So adding is the same thing. We want to get the same exponent. This is 20 and this is 21. So I'm going to change the first one times 10 to the 20. I'm going to change it to 10 to the 21. So if I want to add, I move it left 1. So I get 0.24 times 10 to the 21. Now that it is the same, I could add this one, 4.5 times 10 to the 21. So we're going to add these two together, and you don't need a calculator, 10 to the 21, you just add straight down. So we get 4.74. So 4.74. Multiplication, you do not have to worry about the exponents being the same. What you do is multiply your two numbers and multiply your two powers of 10. When you multiply your powers of 10, you add. So 7 times 5 is 35, and then negative 9 plus 5 is 10 to the minus 4. We add those powers. Now, they want it written in scientific notation, so I need to move the decimal left, so it's 3.5, and when I move the decimal left one, I add 1. Negative 4 plus 1 is negative 3. Division is the same thing. What you do is divide the two numbers, so you do 1.2 divided by 3, and then you subtract your powers because they are the same base. So 10 to the 15 minus 7. So 1.2 divided by 3 is like 12 divided by 3, so which is 4, but there's a decimal place there. It's 0.4. 0.4 times 3 is 1.2. And this one is going to be 10 to the 8th. So your answer is 0.4 times 10 to the 8th. Now we want scientific notation, and 0.4 is not between 1 and 10, so we're going to move it right 1, so we get 4 times 10, and if we move it right 1, and we subtract 1, so 10 to the 7th is my final answer. Subtracting, again, these two do not have the same power for 10. So to subtract them, you want the same power. I'm going to change this second one to a power of 15. So 2 times 10 to the 13. If I want to add 2 to go to 15, I move it left 2, 1, 2. So I get 0.02 times 10 to the 15. Now I subtract them. 1.42 times 10 to the 15 minus 0.02 times 10 to the 15. And I get 1.4 times 10 to the 15, which is scientific notation. You would be able to change them both to 13, a power of 13, but then it may not be scientific notation and have to change your answer. This one you have to multiply your numbers and add your powers for 10. So 1.42 times 2.4 is 3.48, 3.408. So this is between 1 and 10, and all I do for the powers is add 10 to the 28, 15 plus 13. Dividing, you divide these two. 1.42 divided by 2 is 0.71, and then you subtract your powers, so negative 5 minus 13 is 10 to the minus 18. This is not scientific notation. It doesn't say to rewrite it, but let's practice it. So scientific notation, I have to move it right 1, so 7.1 is between 1 and 10. And if I move it right, I subtract 1, so it's 10 to the minus 19. Okay, your homework for this lesson is 1, 2, and 4.